Circles, one of my favorite shapes.
I challenge you to find how many real-life objects we have in the shape of circles on the slide.
A circle, definition, the set of points, coplanar points, equidistant from a given point. Let's comprehend two words before we get this definition. Coplanars, a word we learned earlier in our geometry course semester 1, and the word equidistant or equidistant. Coplanars, remember coplanars are points that lie in the same plane, which is the definition on the top, versus non-coplanar, which is not on the same plane like point G demonstrated. Let's explain the word equidistant. If you can, say the word equidistant with me. Equidistant or equidistant. This is a circle. The point in the middle is called the center. When we connect the center to any point on the circle, we have the radius. Circle with 6 equidistant points. The plural form of radius is radii. All of these radii have x length, and that means their lengths are equal to each other or congruent. A chord, this is the segment whose endpoints lie on the circles, the green line on the circle. A diameter is a special chord. Why is it special, you might ask? Because the diameter is the only chord that goes through the center point. Tangent. Tangent is a line in the plane of the circle that intersects the circle in exactly one point. And the point of tangency is the point where the red line intersects the circle. Secant. This is a line that contains a chord. So secant is an extended chord. Here's an example. In the following figures, identify the chord, radii, and the diameters. Which one are the chords? By the way, radii is the plural form for the word radius. And finally, the diameters. We want you to identify it from the figures on the left. Segment AB, segment BF, segment CE, what do you think it is? Chord, radii, or diameters? If you're thinking chord, you're right. Segment OB, segment OF, segment OD, OE, OC, and OA. What do you think? Would it be, well, we already have the chord crossed out, so radii or diameters. And the last one, by elimination method, we only have the diameters left. We have some definitions. Congruent circles. Defined as the circle with congruent radii. This is a 2, even though the radius is not exactly in the same place, lying horizontally like the pink circle.
So congruent circles, again, circles that have the congruent radii.
Concentric circles. These are circles that lie in the same plane and have the same center. This is the bottom left corner. Arcs. We have the minor arcs and the major arc. Guess which one of these would be minor and which one of these would be called major arcs? 5, 4, 3, 2, 1. It makes sense to have the 2 letter with the curved things on top to be the minor because it only have 2 letters. And the one with 3 letters, one more letter, we have with the curved arc on the top. This is called the major arcs. Let's demonstrate it again. The major arc is the longer arc. AQB is the longer or major arc. The minor arc is the shorter one. AB is the minor arc. One of the major arcs is called semicircle, and this semicircle is half of the circle. Semi is half of the circle, an arc that is equal to 180 degrees. We have some definitions. Minor arc. A minor arc is an arc that is less than 180 degrees. Minor arc is named using an endpoint with an arc above.
This is the notation or symbol in geometry for a minor arc, AB.
A major arc is an arc that is greater than 180 degrees. And we named it with 3 letters in order of the arc, where we can trace it.
For example, here's the major arc ABC. There are 3 letters, and when you're tracing this arc, you will go from left to right. So whatever the letter is, starting on the left, I would go with A first, so this is A, and then I go this way, A, B, and then C. This is the major arc.
If you go out of orders and you go A, B, C, but you go this way, the clockwise or counterclockwise direction will have different measure. Example on arcs. Identify a minor arc, a major arc, and a semicircle given that segment CD is 8 diameters. Identify some minor arcs, some major arcs, and some semicircle. Pause and try. Polygons. How is it related? The inscribed polygon. Inscribed means inside, and the polygon is on the inside. A polygon inside the circles whose vertices lie on the circle, just like the top one. This one, the triangle, is not inscribed. What is the word to describe it when it's not on the inside? Circumscribed. Polygon. A polygon whose sides are tangent to a circle. We have some inscribed versus central angles. These we must know for circle. Inscribed is the blue angles. The blue angle, this point by the way, is supposed to lie on the circle, not outside. Inscribed angle is where we're going to have the vertex, the sharp end, lying on the circle itself. And the central angle is where the angle with the vertex at the center. One of the easy way that I would memorize it is if I can identify the central angle, central start from the center, the vertex start on the center point. Then if it's not central angle, it is going to be inscribed angle. And that's one of the tricks that I use to memorize these. Central angle, not a central angle, it is an inscribed angle. The intercepted arc is another word I want you to know. Intercepted arc is the pink arc. When to use the measure of angle with the sharp end symbol, and when to use the arc with the curved symbol on the letter GLH. On the left hand side, the measure of angle JKH. On this side, we call it the measure of arc GLH, the measure of arc GH. Do a quick review. Pause and answer these questions. Which one is the major arc? Which one is the minor arc? We have a textbook problems and it is given with one angle, 122 degree. When we have angle, we can call this angle an inscribed or central angle. Do you remember which one it is? That's our quick review, getting back to when to use measure of arc and when to use measure of angle. We use the measure of angle, the sharp end symbol. This is the symbol we learned earlier in our geometry course before the unit circle when we add the arc in. The angle, remember the angle of reference? This is the angle with the red curve, and we trace the angle in red. It started with J, K, H. Always trace it in the order given to us by the letter. If I need to find that angle, do you remember what we need to do? We're going to use the arc. We are using the arc notation when we're tracing the circle curve. And I know it's curved because of this symbol, but let's say if I'm not sure, I can go ahead and trace it. If I go through GLH, remember GLH, go this way. This is the big arc length that is bigger than the semicircle, 180 degree. If I trace the angle with GLH but not in order, GLH, this is the wrong arc length that span the wrong way. Measure of the minor arc GH, this is the minor arc. This is the intercepted circle of the angle GKH. Equation of circles. Some of the work related in this unit. Circumference and area work.
Or we will ask you to
remember all the circle terminologies and put it on the paper plate. The other side you can decorate it with some beautiful drawings. Click on the word of your choice, move it to where it belongs. If you need to zoom and make it bigger, you can always put it in the presentation mode. Hit escape to drag the word chord and all the word that is on the bottom of the dashed line to where it should go. And once you're done, don't forget to turn it in Canvas class. Thanks for watching.